5 minutes? Yeah, sure. Okay. So, in my experience, until now, Rust is slightly underrepresented at this conference, and I wanted to change that. But since this is a PolyConf, and we are polyglots, supposedly, Rust can integrate very well into many different languages. Why? We'll see it in a moment. I am mostly a Python developer, but I'm somehow involved in the Rust community. I run Rust Warsaw meetups, and I've written a couple of articles called 24 Days of Rust. You can check it out there. Most other languages to interoperate with each other use a concept called Foreign Function Interface, in short FFI. And these languages usually interoperate with libraries written in C. Rust is not C. Rust doesn't really look like C. You can see, for example, this is a Rust function. And it's not necessary for you to understand all of it. It just counts the number of substrings in a string. This is all native Rust types and returns a native, it's an integer, so it should be the same everywhere. And this can be made to look like C, and by look like, I mean an API and ABI that's compatible with C. It uses a few language features like the no-mangle attribute, which, as it says, disables name mangling, and external C declaration. Also the native C-compatible types, and the unsafe blocks, which are necessary, but that's beyond the scope of the lightning talk. So, if we expose the Rust code in a C-compatible way, we can call it directly from C. We just declare the function, link with the Rust library, and we're done. It works. We can do it in Python. It's very simple. With C types, we can just refer to the library file, and the function will be an attribute on the returned object. You can use CFFI module, which can give you more type safety on the boundary between Python and C, which is not really C but Rust. And Ruby is the same story. Just the FFI gem and declare the library, and we're done. These examples are kind of sorted in order of weirdness. Here's C#, which works pretty well under Mono or under .NET, and it uses the native features of interop services. DLL import and an external declaration is everything that you need to call C or Rust from C#. And I think this is portable to other .NET platform languages. Here's Haskell, where you need to use a language extension in GHC, foreign function interface, which adds a few keywords like foreign import C call. And there's some wrapping around from Haskell strings to C strings, but it's, other than that boilerplate, is rather straightforward. There's Go, which is weird, because you need to declare the function again as a comment before a special import, which has more meaning than normal Go import. There are some CGO flags, CGO directives which specify compiler and linker flags directly in the code. There's also some string matching around, but that's okay. Sorry. The JNI is painful to write and also needs some C code as a glue. There's hope. There's the JNR FFI package. Haven't built an example of that, but hopefully this will ease some of the pain. And there are, of course, many other implementations. There's Node.js FFI package, which actually works. There's pretty easy NIM integration. Basically, if your language can speak to C, it can speak to Rust, and back again, because callbacks are also pretty simple. So, to sum up, here are a few resources, articles, examples, and the official Rustlang book has a whole chapter on FFI. And I think I'm done, so thank you.